Hello everybody, my name is Wael Abdulhamid. I'm assistant professor at University of Bahrain. First, my apology about not being able to join you. I wish you a very fruitful conference. I'll present my research, VARE use in architectural design studios, a case of studying structure and construction. The main objective of my research is to investigate how and to what limit architecture students would benefit from the VARE use in their designs and proposing structural systems. I used my previous work in virtual reality, which was through XML algorithms or certain code that can be used inside the microsimulation function of the virtual reality program in order to visualize a structure system and its construction process. I'm going to display a video of this previous work in order to show the program. Here it is VARE Studio developed by Forum 8, the Japanese software developing company. As we see, we started from tools, microsimulation player, then uploaded a certain XML file inside the microsimulation player, then execute the construction process or the XML file. Inside the XML file, all the structural elements are controlled according to the time and different, of course, variables. I'm going to, of course, before as we see here, through the player, you can accelerate, or the user can accelerate the process and stop or pause it at any time, then go to different camera positions, or even navigate inside the construction or the structure, as we are going to see right now. I'm going to accelerate the video a bit. Right now, yes, it is the camera inside the structure, and it can navigate in different directions and even studying or testing the surrounding environment. This is according to, again, certain scenario. As we see in this scenario, we stopped the construction process here in the left part. As we see, these two stories in the left part, then we execute the whole construction process quickly. Then I'm going to the microsimulation player again, delete the XML file, then upload another one. As we see here, yes, maybe here, yes. Select the file, then delete it, then upload another file, open another file, which is this one, the modified one, which has different scenario of the same structure process. As we are going to see right now, in the last scenario, we concentrated on the left part. Here we are concentrating on the right part of the building, and of course you can pause the structure visualization, and you can navigate to different, whether inside the building, or different positions, whether inside the building or even outside the building, as we see right now. I'm going to close the video, then back again to the presentation. The steps used in making the VARE structure model. The structure system should be divided into different units according to the time which each unit would be constructed in. So each group, let us say in other words, each group would be constructed in one time, should be gathered or grouped as one unit. So for example, columns of ground floor, or up even part of them, if we want to see them through certain scenario as one part, then they should be modeled separately and imported separately in the VARE program. Imported, I mean, either the whole ground floor columns or A part of them should be a separate model, and a separate model imported as separate model inside the VR program. Then the XML code controls the visualization order of each modeling object or structure unit. These are two screenshots from previous researches. On the left here, screenshots of VR program showing the structure elements at a certain stage of a construction process. On the right here, the two screenshots showing the ground and the second floor of a structural system. And as we see here in this research, I added a certain textual data related to the stage itself. So in the ground floor, for example, or any stage, it has different data, construction of course, and constructional and structural data. Both of them can be displayed and related to a certain stage of the construction process. Virtual reality in learning constructivism is a theory of knowledge acquisition in which humans construct knowledge by learning from their experiences. The experiential nature of virtual reality supports the constructivist approach to learning. Of course, we know that virtual reality helps in teaching by providing an environment that allows the users to experience scenarios and situations rather than imagining them. Architecture design studios. The study was conducted into two design studios with the same design complexity level. They had two different programs, but with the same, again, design complexity level in terms of zoning, different spaces, functional relationships between the spaces, and so on. Students were required in this design level to provide and present the details of the structural system in terms of type, structural elements, expansion joints, and span. These academically required points in the structural system were the study focus. The student made the digital models, then import them to the virtual reality program. There were lectures and presentation in order for students to use the functions of the VR program. During their use of virtual reality, students were asked to record their design developments and modifications. These are two screenshots from student work examples. As we can see at the beginning stage, the models were on abstract level. The methodology used in this research was so simple. It was depending on the students' records, where the students were asked to record each design decision or modification they may take. These self-records helped in revealing the design actions and the rationale behind them. Two methodological ways were used. First one, qualitative analysis through analyzing the self-records provided by students, and the second one, quantitative analysis through conducting a questionnaire that was designed to highlight the effect of VR on how students select and design the structural system. These are the effects that were recorded from the questionnaire results. As we can see, first, there is no main effect, no weak effect recorded here at all. Then the major effect here, which is highlighted in black here, it is above average effect. While the second one is average, as we see here. This is the average effect, and it is the second trend recorded. So the effect, it varies from below average to above average to strong. The qualitative observations and analysis were necessary to explain both trends and remarks in the quantitative results of the questionnaire. In the questionnaire, we have four parts. Uh, First one is structure system selection. This is a case, just a case of a student work, and inside this structure system selection, it is observed that when using a different structure system, the VR rule appears effectively in helping the designer to design the form. Here, this part of the design, which is cylindrical part, the virtual reality use appeared effectively in how the student finalized the design and made the form of this part. The second part of the questionnaire, structure system elements and expansion and settlement joints. Students stated that VR use gives them more clarity on expansion and settlement joints, connections, and their spatial relationships. Most of students stated this in their self records, and as we see here, a plan view of one of the students' work. The second one is constructional processes and their scenarios. Forms and designs with many parts and elements have different scenarios. In these designs, which may be described as complicated designs, virtual reality helped those students to propose some scenarios and different scenarios, while students with simple designs, they had only one or maybe two scenarios, only one or two, and they stated that virtual reality use was not effective, yet not weak. Of course, from this effect, the observation is so clear. When we have a complicated form like this, or it can be constructed in different scenarios, virtual reality can help a lot in proposing these scenarios. The relationship between structural system and architectural design. Around half of the respondents or the students record that the effect of VR use as above average and strong, while almost half of the respondents view that the effect of VR use as average and below average effect. This observation partially resulted from two things. One thing is that the abstract level of forms used in virtual reality by students at the initial design phases or stages. And the second is that the most students chose to make the final modifications of form and facades in the computer modeling programs they used to use before or familiar with. This is one of the designs of the students. And the above two images here, we find that the virtual reality, two screenshots from virtual reality program, and below one screenshot from 3D Max program. Conclusion: the virtual reality use increases the awareness of designer during the designing in terms of the structural properties and components assembly of the structural system, the individual subjective way of visual design thinking and perception that varies from one to another has a recorded effect on the VR use. In other words, we can say that students who have more experience in modeling computer programs become easier and faster more familiar with the VR program. A wide range of variety in the levels of virtual reality use and visual design thinking was evident among the students. However, both the simple methodology applied and the various design factors neutralized overcome this range effect. Thank you very much for listening, and again I wish you a very fruitful conference. Thank you.